Hi everybody. Today I am going to show you how to solve a triangle. As we know, solve a triangle means to find the values of unknown sides and angles. If a triangle is right angle, we can use trigonometric ratios and the theorem of Pythagoras to find unknown sides and angles. If it is not a right angle triangle, then we have to use sine rule and cosine rule. So first I am taking example of right angle triangle. Suppose a surveyor, he measures the angle of elevation of the top of this perpendicular building from this point, because he wants to calculate height of the building. So what is needed from this point C? He will make the line, horizontal line to the vertical, that is virtual lines, up to the top of the building. So first task is to measure the angle of elevation of the top of this building. So what you will do? You will make this line, these red lines, at an angle of 25 degree. So this angle is called angle of elevation. Now he moves 100 meter ahead. Then he will measure again the angle of elevation at an angle 50 degree. And this second position, it is from the face of the building at a distance of x. As well, this angle, it is 90 degree. So it is a right angle triangle. And if we put the name of the vertex ABD, as well the height of this building is h, then we have all the dimensions and the angles to find the height of the building. So what we will do first? So here there is two triangle ABC, another triangle is ABD, and both are right angle triangle. So we will consider first ABC, and this angle tan 25 equal to height divided by base, because it is right angle triangle. So easily we can calculate h equal to tan 25 x plus 100, and putting the value of tan 25 we can get the equation as this one. Now considering triangle ABD, we will use the same tan 50 equal to height by base, because this triangle height and base. So h equal to this equation, and putting the value of tan 50, we get the equation as h equal to 1.1917 into x. So these two equations are same. So equating these two equations, we can write like this. And bringing x term on the left hand side, easily we can calculate the value of x. It is 64.282. Now putting this x value in this equation, easily we can find the value of h. It means we got the height of building 76.60 meters. That's all. It is done. Height of the building. Now in the next slide we'll see how to find the area of the triangle. I am removing the building, so triangle will be very clear to look at. Now here I put here yellow color to indicate that we need the area of ADC. But we know ABC is a right angle triangle, as well ABD also right angle triangle. So if we find the area of these two and if we subtract, easily we can get the area of ADC. So let's see. Area of triangle ADC we need to find. So we'll use the formula to find the area of the triangle. If it is right angle triangle, base half into base into perpendicular height. Very easy equations. So x already we got in previous slide, and BC we can do it very easy way, x plus 100, and this one h also we got in previous slide. Now we have to use these values to find the area of ABC. We'll use these equations, very easy, half into base into perpendicular height. Half into base into perpendicular height means height of the building. So we got the area this. Now for second triangle ABD, same formula we'll use and we'll get this area. Now subtracting these two, we get this yellow colored ADC triangle. So we get the area of that triangle, 3830 square meters. So area of the triangle. Right now you know how to use right angle triangle formula to find the area of the triangle. But if the triangle is not right angle triangle, then we have to use sine rule and the cosine rule. So let's move ahead to see that. This is a triangle. It is not right angle triangle. So vertex are ABC and sides are also small lowercase ABC. Now for the triangle ABC, sine rule, how it states? Very easy equations. A by sine A equal to B by sine B equal to C by sine C. This is sine rule. To solve a triangle which is not a right angle triangle. But there is a constraint for that, because this rule may be used only if these 2 points are given. What are those 2 points? 2 sides and an angles are given. 2 sides and any angle, one angle to be given, or one side and any 2 angles are initially given. Then we can solve the triangle. So let's see an example in the next slide. So the triangle is slightly twisted. So A, B, C are the vertex. We have A equal to 16 centimeter, B and C we have to find. We are given only one angle, 70 degree. Also given another angle, 50 degree. So two angles are given and one sides are given. We have to find these two sides as well as remaining third angle. Third angle, it is very easy to find because we know summation of these three angles of a triangle is 180. So 180 minus given two angles, we get 60 degree. So angle of C is 60. So it is very easy to calculate. So we know now three angles. Now we will use the sine rule. We know it very well what is sine rule, because this sides divided by this sides divided by opposite angle, this sides divided by this angle, this side divided by this angle. So accordingly I have written that. Now we have to take these two to find the B. Again we will take this and this to find the C. So these two we can find by transposing. We can find B equal to 19.63. So already it is transferred here. Now for the C, we can write this, and by transposing we can find C. So it is also gone there. As we know all the things, all the items like sides we know, angle we know, so we can find the area. So area of the triangle, what is the formula? Half AB sine C. Because if we take A and B, then we have to take the angle in between these two sides. So it is sine C. I got 136. Again, for checking, I am using other equation like A and C. So I have to take this angle. So sine 70. So I got 136. So it is very easy to find the area of a triangle using these equations. So this is the example of sine rule. So in the next slide, we'll see about the cosine rule. So all the vertex and the sides, lowercase ABC. So for this triangle ABC, cosine rule, what it states? It says that a square equal to b square plus c square minus 2bc cos a, or b square equal to remaining a square plus c square minus 2ac cos b, or c square equal to a square plus b square minus 2ab cos c. These three are the cosine rule. We have to use these three. Then there is constraint. What is that? Three sides are initially given. If three sides are initially given, then you can solve the triangle. If two sides and included angles are given, you can solve the triangle. So let's see an example in the next slide. Slight rotated triangles. Vertices are ABC, having three sides, A equal to 40, C equal to 30, and B we have to find. And in between A and C, one angle 65 degree is given. So for the triangle ABC, cosine rule, what it says? We have to use this formula. b square equal to a square plus c square. Already we have seen that in previous slide. B square equal to a square plus c square minus 2ac cos b. This is 65. So easily we can find b square, then doing a square root we find b equal to 38.545. So this b is this. Now applying the rule, which rule? This is sine rule. We have to apply now sine rule. So applying this, because here only this sine c is unknown, so we can find the c, sine c equal to this. So c equal to 44.83 degree and 135.17 degree. This comes actually 180 minus of this. So we got two values for c, but we have to check either this value is valid or not. This is okay, of course, but this one we have to check. So in the next slide we will see that. So this equation in the previous slide I brought it here. As I told, this 135.17 degree is not possible in this triangle. Why? Because if this C is 135 and this is 65, so adding these two it comes 200.17. But as we know, summation of these three angles, it will be maximum 180, but it is more than 180. So this result is not valid. We are cancelling this. So we will use this one, 44.83. So if we know C equal to this, we know this B, so easily we can find this subtracting from 180. So A we got 70.17 degree. Now it is very easy to find the area of the triangle. Half AB sine C, because if there is AB, so angle will be in between that A and B, in between is C, so C angle we have to use. Then I got 543.49. To check, I am taking other sides, AC sine B. I got 543.78. It is of course very close and same, because due to degrees here some decimal digital, I mean like I have here taken two decimal. If it would be more, for this reason maybe this small amount variation we find here, but both are same. So we understood how to find the right angle triangle area. Also right now in last two places we saw how to find the area of the triangles which are not right angle triangle. So that's all for today. Thanks for watching.